Okay, so 7.2, using using proportions to solve geometric problems. Everything we do is going to be using proportions, using proportions, using proportions. That's what we did yesterday. Okay, to review that. Sorry if it sounds like I'm yelling because I feel like I have to push everything out. When we go through these guys, you've got to understand how to solve proportions. If you're struggling with that, then you need to come in, see me, whatever, because if you don't, are you going to be able to do any of these problems? No. Okay, so you have your pinout. Okay, scale drawings. A scale drawing that is the same shape as an object that represents the scale is a ratio that the scale represents the ratio that describes how the dimensions in the drawing are related to the actual dimensions of an object. Okay, that's a whole blah. Okay, scale drawing. I want you guys to write down a couple examples. So can someone give me an example of a scale drawing?
Like a reflection.
No. Well, it's the same image, but it's smaller. It's scaled down.
When they draw out a house.
A floor plan of a house. Would that be a scale drawing of the big house?
It's gonna be.
Yes.
Accurate.
And it's remember, it's like every inch equals, or probably every centimeter equals so many feet, right? They have a scale for that. What other thing?
Like engineers who build like small scale models of their buildings.
Yeah, okay, so a model, not a drawing, but a model, right?
Would
They
it
have
be
scale models of their buildings or whatever they're gonna make. Yes?
Blueprint also.
A blueprint.
Legos.
Legos, I guess if you really measured it, could be a scale model of. What about a map?
Yeah.
A map is a scaled down. Remember when you had to learn to read a key on a map? You had to measure with a ruler, and so you had to do that. So we use scale a lot in our life, don't we? I mean, we really do. So we're going to be figuring out that. And remember, I told you the 3, 2, 5, or whatever it was on that was a scale. It is. That's the ratio to the drawing. So I can scale it up or I can scale it down. So additional properties of proportions. Yesterday's note just had a 1 and nothing else. And you're like, well, if you number 1, you also have to have a number 2, right? Well, here's the 2, the 3, the 4. So reciprocal property, if A over B equals C over D, then B over A equals B over C. What did I just do to both of my, I reciprocated them, right? That's kind of a duh thing, right? If I do I have to reciprocate both of them? Yeah. I can't just reciprocate one, I have to do both. Okay, the next property is if A over B equals C over D, A over C equals B over D. How did I get from the left proportion to the right proportion?
You were talking.
I took my numerators and made a proportion, yes? And I put my denominators and made a proportion. Could I reciprocate both of those as well?
Yeah.
Yes,
Yeah.
as long as I reciprocated what? Both. Now, the reason why I'm showing you all these different ways is if we can put our variable in the numerator, it makes our life a lot easier and our brain thinks about it better. But you don't have to. You can just deal with it. Okay, the other thing is if A over B equals C over D, A plus B divided by B equals C plus D divided by D. So it's the denominator plus the numerator over the denominator. See that? Okay. And I'm going to show you some problems where actually we have a problem that we can use 4 with, or we can use our other properties with. So you can do it either way, but it adds a little extra
On
step.
the homework, will it ask if it wants us to use?
No, you just pick which property you want to use.
So we can do even number 2 if we want.
Yeah. Yeah. What's going to happen is you're going to do, you're not going to know 1, 2, and 3. There's no difference in the rules. There's absolutely no difference in the rules. It's just how I wrote them. Does that make sense?
Yeah.
I can put them different places. Now, on 3, I can put my numerators together, my denominators together, and make it. But can you quit clicking? Thanks. Can I take the numerator of one and put it with the denominator of the other? No, because they're different parts. When I show you the picture, you'll see why. They're not. No, I can't take A and B and put them together. I didn't do that with anything. We do cross multiplication, but I can't do any rewriting. Does that make sense? Okay, so because the corresponding parts can be grouped together, and I'm going to show you that here in a second. We only have 3 examples, but I am going to show you different ways we could do it. So, on the first example, I have X is between SU and between UR is 5, and RV is 20, and RT is 8. Yes? Okay, so not RT is 8, VT is 8. So what is RT? 28, because that's our segment addition that we did in topic 1, right? We've done this before. So it says find the value of X. So I need to find X. There's several ways we could do it. Would anybody like to set up one?
Could you do 5x, or would it be x over 5?
X over 5 equals what?
20 over 8.
8 over 20.
8 over 20. Why does it have to be 8 over 20? Not
Because 8 is in like
they,
line with the x.
they're corresponding parts. You guys see what I mean by corresponding parts now? The X corresponds to the 8, doesn't it? And the 5 corresponds to the 20. Now, I could write it like this. Could I do anything else? Could I do it another way? Could I do X over 8 equals 5 over 20?
Yeah.
What did I do there?
You did the b, c.
I did the smaller corresponding, making a ratio, right? And then the bigger. But you notice the X and the 5 are on one side. They had to stay connected, didn't they? Could I reciprocate the 5 and the 20? No, not unless I reciprocated the other one, right? So let's, what?
Can't you reduce the 5 over 20?
Yes, we can. We're going to do both of these right now, and we better come out with the same answer, right? Okay, so on the left one first, you guys want to reduce 8 and 20 before we start? Yeah, we always should reduce, right? Smaller numbers.
We can go by 4.
We can go by 4. Good job for going for 4 instead of 2. So it's going to be what? 2 over
2 over
2.
5.
5.
5.
So then I'm going to
Actually, it's 4, it's 4, it's 4.
Oh, no.
Yes, it is.
No, 4 goes into 25.
5 is 20.
No.
Oh my gosh. I'm dumb.
It's okay. No, you're not. You're the one that said reduce. Okay, so now I multiply X by what?
2. 5.
5. This is where I do my cross multiplication.
It would be 5x
So it'll be 5X
equals 10.
equals 10. So X equals 2. So when we do the other one, I better get X equals 2, right?
Yeah.
Okay, so you guys want to reduce 5 and 20?
Yeah.
Nicole, this is the chance to save yourself. What does it reduce to?
1 over 5, 4 to 5, 4.
1 over 4. Good job. Okay, now I'm ready. Can I reduce sideways, guys? Well, first of all, there's an equal sign in the middle, and I can't do it there, right? But I don't, side to side, I multiply, I don't reduce, do I? I'm not dividing. Reducing is division. I'm not dividing, am I? Okay, so 4 times X and 1 equals 8. So X equals 2. Now, could I reciprocated both of these fractions and gotten the same answers? Yep. But I'm going to tell you, putting the X in the denominator, we don't like to do it. Our brain goes, ah, and freaks out and wants to leave the room. And if our brain leaves the room, we're not accomplishing much, are we? Okay.
Now, on that one,
This one?
would you do the same thing as what that was, like X over 4
Can
equals?
Okay, now, what's X this time, though?
RS the longest?
It's the whole thing, right?
This would be,
So, remember how I said that we had the number 4?
Mhm.
We had number 4. We could add 2 things together. So, here, it would be X over what? 4, right?
Oh, that's that part, right?
And what corresponds to x on this side?
3,
Six over
6.
six.
What?
9.
3 plus 6.
I'm confused
Okay.
on that.
We will, but I'm showing you that it's 3 plus.
Wait, now
Okay, now everybody look at the picture again. X is that whole side RS, isn't it? The whole side. So what corresponds to RS? It would be what? RT, which would be the whole thing, wouldn't it? Which would be 3 plus 6. What corresponds to 4? 6. So 6 goes here.
So whatever's a. What I'm confused on that part where you got how the 6 corresponding to 4. Is it just like looking across?
Well, okay, you see these pieces?
Yeah.
Like this piece is smaller than this piece.
Yeah.
So which piece is bigger? Like
The 4 and 6.
4 and the 6, because so those are corresponding parts. Because actually, guys, can you see 2 triangles here? There's
Yes.
one big triangle and there's one smaller. So that's really what's
And
corresponding.
then there's a weird shape.
Well, no, it's a quadrilateral. That's not
So
weird.
weird.
Okay, so how do I solve this?
You can multiply across.
Oh, this is what?
That's
Well, you can add that.
This is 9.
Yeah.
And then you have to reduce.
Oh, and then I can reduce, right?
Yeah.
So 9 and 6 reduce to what?
3
3 over 2. So I'm going to rewrite it just because we got a lot going on, right? And now I need to do what?
Now multiply across.
Cross multiply, so I get 2x equals 12. So x equals 6.
That was a good guess.
Okay? Now, we're going to do another one, but I'm going to show you another way to do it. Oh, is there anybody okay with that one? Got it written down?
Wait, I want to do mine myself.
Oh, you want to do it by yourself? Okay, you guys do it by yourself.
Let's see if I know how to do it.
You guys do it by yourself. It's exactly like the one we just got done doing, right?
Sort of.
Yeah. Because I want the whole thing.
Oh yeah.
Wait, will it actually always be on top then?
It doesn't have to, but I like to put it on top. Because remember we said that you can reciprocate them and it's fine. I personally always put X on top.
So he's trying to cheat.
It's not the right answer anyway.
I could
Yeah, it
see
is.
it on your body.
No, it's not.
It was on your body.
I know it was, but it's not right.
Yeah.
No, it isn't.
Yeah, it is.
So I think I just did it
That's
right.
what I got.
Wait, I'm really confused. Man.
That's fine.
Why
But
do you use
this
that?
is not. Don't even.
Oh.
Don't even.
That's what I got.
Okay. So, Jaden, how did you do it? Don't change what you're doing. Don't change. Don't anybody change what you're doing.
What did
Okay,
you-
finish.
what
Go
did
ahead
you
and finish.
do?
Okay.
10 over x
Okay, shh, guys, listen.
equals.
You put 10 over x.
How did you get a y?
Okay, no. That's. I'll explain this in a second.
I did.
I'll explain. Shh. Okay, 10 over x equals.
I did that. I did that.
15 plus 18 over 18. Wait, I put x over 10.
You said 10 over x.
Yeah.
Okay, because I was gonna say that's wrong. Okay, so you put x over 10
Yeah.
equals 15 plus 18 over what?
I mean 50.
15.
That's where I messed
Okay,
up.
why does it have to be over 15?
Cause it's corresponding.
The 10 corresponds to the 15, right?
Yeah.
Okay, so did everybody get that? Everyone set it up like this?
Right,
No.
Yeah.
I messed up.
I got
Okay,
to
so
that
fix what you messed up.
part. Do you want us to
Blaine,
rewrite?
did you do this?
Yeah,
Okay,
but I got it right though, so.
okay. So then Blaine, what do I do from here?
You add the 15 and 18,
Okay, so that's 33.
then you multiply it by 10.
Can't you reduce
Do you want to
those?
reduce? Anybody want to reduce?
Can't you
Yeah.
reduce those?
3.
3.
So this would be 11 over 5.
I had the math right. I just put
Okay.
a 3 instead of the 11.
Oh, because you
I
were
don't remember
put the what you were reducing by.
Yeah.
Okay, then cross multiply, right?
Yeah.
5.
So 5x equals 110
So x equals 22.
divided by 5. So x equals 22. So x is 22. You said you got 12, Bladen, so you didn't get it right.
No, I was joking
Oh.
about that. I got
Okay.
22.
Now-
Okay, I was on except for that reducing part.
Okay.
Until I put that 3 down instead
Oh.
of 11. So
Okay.
I was good.
So,
I didn't remember that.
Everyone okay? Like you found your mistake. Kyson, did you find your mistake?
That was correct.
You were?
No.
Did you find your mistake?
Yes.
Okay. So, what did I do? Because I'm not wrong, but I'm not done.
You put a y in
I put a Y in there.
Why would you?
Okay? Why would I do that? Because guess what? Because when I first did this, I didn't even look at the rules. I just started doing the examples. And guess what I did with Rule 3? I forgot it. Okay? I forgot Rule 3. So this isn't all of my work. This isn't all my work. This isn't where I stop. I did get the right answer. What did I have to do with my 12?
Times it by.
Not times.
Where'd you get that 12 from, though?
Okay, I just put a variable here. I just put a y there.
So did you add it with 10?
I have to add it with 10. If I add 10 to it, what do I get?
22.
22. So did I get the right answer?
Yeah.
But where
Did I do it the just a second. Did I do it the same way?
No.
No. Juan, what is your
Where'd
question?
you get that 12 from, though?
Okay, right here. My work is right here. I put a y on JM, didn't I?
So you put.
I found JM and just added the other part and got it.
So you put
but-
y.
I put y over 10 equals 18 over 15, reduced 18 and 15 to 6 and 5. So 5y equals 60, so y equaled 12. And that was part of it, and then I had to do what? Add the 10. But this addition, isn't that what we do right here?
Yeah.
Yeah. So, I think geometry should be very practical, right? And I don't think, I am never going to make you remember the volume of a geometric pyramid prism.
This you
Ever.
will.
No, I won't. You'll have your notes with it in there. If you choose not to take notes, then that's your choice to get the problem wrong. Because is anybody going to remember that formula? No. Okay? When we start talking about surface area and stuff, we're going to talk about area of rectangles and squares and adding those all together. We're not going to remember the whole big formula. So, am I wrong the way I did it? No. I used what I remembered. Is there a way that is more efficient?
Yes.
Yes. Now, if I would have stopped at 12, would I have been wrong?
Yeah.
Yeah, because it wants what? The whole thing. So what I'm telling you guys is I'm very rarely in my classroom going to tell you have to solve it with this formula if there's other ways to do it. It will happen once in a while because it'll be a process we're learning. But you have to finish it out right, okay? So I don't care which rule you use. Like you were asking Riley, is it going to tell me which one to use? No, you just have to figure out which one you want to do. Okay? So that's it. And now you have